All right, this is section 5.4, sum and difference identities or formulas. So the important ones for today are the sum or difference formulas in your purple sheet or on your purple sheet. We're going to use the sum or difference formula to find an exact value. So the sine of pi over 12. I can't look at the unit circle and find that. But I do know that I could find two values that are on the unit circle that add or subtract to pi over 12. I happen to know that 4 pi over 12 minus 3 pi over 12 indeed makes pi over 12. And 4 pi over 12 is actually pi over 3 when I simplify it. 3 pi over 12 is pi over 4. So I can subtract pi over 3 minus pi over 4. So I want sine. So I'm going to write the sine of pi over 3 minus pi over 4. Now I use my difference identity for sine. That says the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. And now I can use my unit circle. The sine of pi over 3 is square root 3 over 2. The cosine of pi over 4 is square root 2 over 2. The cosine of pi over 3 is 1/2. The sine of pi over 4 is square root 2 over 2. I multiply, I get the square root of 6 over 4 minus the square root of 2 over 4. They have the same denominator. Square root of 6 minus square root of 2 over 4 is my answer. You cannot combine those square roots now. You can combine the multiplication step, but not the subtraction. So let's try that same thing with cosine of pi over 12. Well, we know that pi over 12 is made by taking pi over 3 minus pi over 4. For cosine, the rule is a little different. We take cosine of the first times cosine of the second plus sine of the first times sine of the second. Just following that formula from our sheet. So the cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root 2 over 2. The sine of pi over 3 is square root 3 over 2. The sine of pi over 4 is square root 2 over 2. We multiply and we get the square root of 2 over 4 plus the square root of 6 over 4. Add those together. I have the square root of 2 plus the square root of 6 all over 4. So now we have the ability to find more values from the unit circle. We can't find everything yet, but we can still find more. All right, to get 75, let's see, I could take 90 minus 15. That's not helpful. I could do 30 plus 45. So let's break 75 into 30 degrees plus 45 degrees. So the cosine rule says cosine of the first times cosine of the second minus sine of the first times sine of the second. The cosine of 30 degrees is square root 3 over 2. Cosine of 45 is square root 2 over 2. Sine of 30 degrees is 1/2. Sine of 45 is square root 2 over 2. And combine just like we were doing, square root of 6 over 4 minus square root of 2 over 4. Our answer is square root of 6 minus square root of 2 over 4. All right, sine of 75. I wonder if there's another way I could do it. Absolutely. I could do 120 minus 45. That sounds awful to me, but I could. I'm going to do 30 and 45 again. Sine of 30 plus 45. So the sine rule is sine of the first times cosine of the second plus cosine of the first times sine of the second. Sine of 30 degrees is 1/2. Cosine of 45 is square root 2 over 2. Cosine of 30 degrees is square root 3 over 2. Sine of 45 is square root 2 over 2. Multiply, I get square root of 2 over 4 plus square root of 6 over 4. And combine into one fraction to have our answer. You'll see a lot of square root of 2's and square root of 6's over 4. Okay. Now there's another way we can do this. We're going to find the exact value of the sine of u plus v, given that the sine of u is 4/5 and u is between 0 and pi over 2, and the cosine of v is negative 12/13, where v is between pi over 2 and pi. So I'm going to draw myself a little picture first. U is between 0 and pi over 2, which means U is in this first quadrant. I know that the sine of U is 4/5, so opposite over hypotenuse. A little light Pythagorean theorem would reveal that the other side is 3. V is in the second quadrant, so I'll draw myself a triangle there. I know the cosine of V is negative 12/13, and a little light Pythagorean theorem tells me that this should be 5. Now I can do everything I need. I want the sine of U plus V, so I'll break that apart using my rules. It's the sine of U times the cosine of V plus the cosine of U times the sine of V. Using my picture, the sine of U is 4/5. The cosine of V is negative 12/13. The cosine of U is 3/5. And the sine of V is 5/13. This is going back to our SOHCAHTOA stuff. So we multiply, we get negative 48 65ths plus 15 65ths. And they both have the same denominator, so I add them together, giving me negative 33 65ths. Simplify if I could, but I can't. So there's our answer. All right, we'll find the exact value of a different one. These are similar numbers, just set up a little differently, and we're going to find a cosine of U plus V this time. So I'll start off with a picture. U is between 0 and pi over 2, so it's in the first quadrant. We know that the sine is 12/13, and I happen to know the other side should be 5. V is in the second quadrant. It says the cosine is negative 3/5. A little Pythagorean theorem will give me a 4 for the other side. Now I'll break apart my cosine. Cosine of U times cosine of V minus sine of U times sine of V. The cosine of U is 5/13 using my SOHCAHTOA. The cosine of V is negative 3/5. The sine of U is 12/13. And the sine of V is 4/5. Now you may notice, I could simplify the 5s in this first fraction. I don't recommend doing that because if you simplify, then you'll have to work to get a common denominator, whereas if I just multiply, they'll have a common denominator. So I get 15/65 minus 48/65. Negative 15 minus 48 makes negative 63/65, and there's our answer. All right, now we're going to write it as an algebraic expression. So for this one, we know the arctangent of 1. Arctangent of 1 is pi over 4. So we have the cosine of pi over 4 plus arc cosine of x. Now I can rewrite this. It's a sum, so I go cosine of the first times cosine of the second minus sine of the first times sine of the second. All right, cosine of pi over 4 is square root 2/2. Cosine of arc cosine of x is x. Sine of pi over 4 is square root 2/2. But what is sine of arc cosine of x? This is where we want to have a little picture. Arc cosine of x means adjacent over hypotenuse, x over 1. So that's the square root of 1 minus x squared. So sine is that over 1. So I'll factor out my square root 2/2 in this case. I have x minus the square root of 1 minus x squared for our final answer. All right, very, very similar. All right, we're going to run this one very similarly. We've already got arctangent of 1 is pi over 4. All right, so we have the sine of pi over 4 plus arc cosine of whatever x is. Using what we just used, we'll rewrite this as sine of pi over 4 times cosine of arc cosine of x plus cosine of pi over 4 times sine of arc cosine of x. All right, sine of pi over 4 is square root 2 over 2. Cosine of arc cosine is x. Cosine of pi over 4 is square root 2 over 2. We just figured out that the sine of arc cosine of x is the square root of 1 minus x squared. And now our answer is going to look very similar because I can factor out that square root 2 over 2. And there's our answer. All right, so we are going to verify now. This is a cofunction identity. This is one that we've had before. We've used this, but we're going to show why. All right, we have cosine of a difference. So I take cosine of the first times cosine of the second plus sine of the first times sine of the second. And we are hoping that'll equal sine of x. Well, the cosine of pi over 2 is 0. And the sine of pi over 2 is 1. 0 times anything is just 0. 1 times sine of x is just sine of x. And hey, look at that. That's what we were trying to get to. And we'll prove the other way around too. We'll do the sine of pi over 2 minus x. So we take sine of pi over 2 times cosine of x minus cosine of pi over 2 times the sine of x. All right, sine of pi over 2 times cosine of x, sine of pi over 2 is 1. The cosine of pi over 2 is 0 times sine of x. All right, I get 1 times cosine of x is cosine of x minus 0 times sine of x is 0. But I wanted it to equal negative cosine of x. Well, that didn't happen because this isn't the actual identity. It's actually positive cosine of x, and then it does work, and we're good. All right, we're going to simplify these. So cosine of theta minus 3 pi over 2. Cosine of a difference, we take cosine of the first times cosine of the second plus sine of the first times sine of the second. Cosine of 3 pi over 2 is 0. So I have cosine of theta times 0. Plus sine of theta times sine of 3 pi over 2 is negative 1. So I have 0 plus sine times negative 1, which is just negative sine of theta. Tangent gets a little bit more complicated. Tangent of a sum, I take tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. All right, the tangent of 3 pi, it is 0. So we have tangent of theta plus 0 over 1 minus tangent of theta times 0. Well, tangent of theta plus 0 is just tangent of theta. 1 minus 0, we have tangent of theta, or tangent of theta over 1. All right, a few more to simplify here. This time the theta's last. That's okay, it'll work the same. Sine of a difference, I take sine of the first times cosine of the second minus cosine of the first times sine of the second. Well, the sine of 3 pi over 2 is negative 1. The cosine of 3 pi over 2 is 0. Oops, theta. So I get negative cosine of theta. Tangent of 2 pi minus 0. All right, I take tangent of the first minus tangent of the second over 1 plus tangent of the first times tangent of the second. The tangent of 2 pi is 0. So 0 minus the tangent of theta over 1 plus 0 times the tangent of theta. That makes my numerator negative tangent of theta. My denominator just 1, so it's negative tangent of theta. Now we're going to use this to solve. In order to solve, we're going to spread these out. We're going to make it look worse and then make it better. So sine of x plus pi over 4. I take sine of x times cosine of pi over 4 plus cosine of x times sine of pi over 4 plus sine of x minus pi over 4 is sine of x times cosine of pi over 4 minus cosine of x times sine of pi over 4. That should equal -1. The reason this is helpful is because cosine x sine of pi over 4 cancels. Our like terms can add together. I get 2 sine of x times the cosine of pi over 4 equals -1. I also happen to know the cosine of pi over 4. It is square root of 2 over 2. And so my 2's cancel. I have square root of 2 times the sine of x equals -1. Now when the real fun starts, we divide by the square root of 2. I get the sine of x equals -1 over the square root of 2. But to get ourselves to a point where we usually see it, we'll multiply by the square root of 2. So the sine of x equals negative square root 2 over 2. This is said to give the answers between 0 and 2 pi. So between 0 and 2 pi, where's the sine? Negative square root 2 over 2, 5 pi over 4, and 7 pi over 4 are our answers. All right, another one, very similar, except that we got pi over 2 and 3 pi over 2. We're switching it up. So first of all, spread them out. I get sine of x times cosine of pi over 2 plus cosine of x times sine of pi over 2 plus sine of x cosine of 3 pi over 2 minus cosine of x sine of 3 pi over 2 equals 1. All right, combine my like terms. I don't have any, but I can figure out each of these values here. So cosine of pi over 2 is 0. Sine of pi over 2 is 1. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. So I'm left with 0 plus cosine of x plus 0 plus cosine of x. Combine my like terms. I have 2 cosine of x equals 1. And now we can solve. Divide by 2. Cosine of x equals 1/2 on the interval of 0 to 2 pi. Cosine is 1/2 at pi over 3 and 5 pi over 3. All right, you will have an assignment to practice some of this.